today we're going to be talking about exponentials 1. In this video, because I'm going to make a bunch of these videos, I'm going to be solving these 4 problems. If none of these 4 problems are what you're looking for, it's probably in another video. Alright, for our first problem, to solve and graph an exponential, I have 2 raised to the x. 2 is what is known as my base function here. So I'm going to make a table and I'm going to solve. The numbers I always use are these 5. I don't know why, just at some point I was taught to use them, and I've always used them my entire life. Or from whenever I was told to use them. So now this is just simply about understanding exponents and being able to solve. So f of negative 2 equals 2 raised to the negative 2. When I have a negative exponent, that flips my number. So now I have 1/2 squared, 1/2 squared. I square the top, square the bottom, that gives me 1/4. If you don't remember this, go back to my exponent videos and watch them. The next one is negative 1. So 2 raised to the negative 1. The negative means I flip it. Then add to the first power, which just gives me 1/2. Now this one's easy, because anything to the 0 power is just 1. I'm not going to plug it in because of what I have. And I'm trying to keep this video shorter, even though I have a lot of information to go over. So then f to the 1 equals 2 to the first, which is just 2. And then f to the 2 equals 2 raised to 2, which is 4. That's how you solve all of them. It's pretty simple as long as you understand exponents and squaring stuff. Now, got my board, we're going to graph them. Now there's 4 ways an exponential can look. I'm going to show you each way. Alright? We have growth and decay functions. Growth means it's growing, decay means it's going down. Not too difficult. Alright? And I'm just going to graph all 4 on the same thing, and I'm going to color code it. So this is going to be my pink one. So now I just graph the points. So negative 2, 1, 2, 1/4. Doesn't have to be exact as long as it's close enough. Negative 1, 1/2, 0, 1, 1, 2, 2, 4. Alright? As you can see, it grew pretty quickly. And that's what an exponential looks like. It starts off very, very slow, then all of a sudden it shoots through the roof. Alright? So this is an exponential growth. An exponential growth is a number increases at a constantly growing rate. So it starts off growing very small. 1/4 to 1/2 is very small. And then it starts getting bigger, then bigger, then bigger. Then the next one would be 8. And then the next one after that would be 16. So it'll keep growing larger and larger and larger. So that's what an exponential growth is. It's growing, the number continually gets bigger. Alright, the last one we did was a growth because it had a whole number here. Alright, anytime you have a number in between 0 and 1, right, it is a decay because it's shrinking. Alright, don't get confused and say it's just a fraction every time, because if I have 3/2, that's actually 1.5, and that's a growth. It has to be between a fraction or a decimal between 0 and 1, so 0.5, 0.75, 0.3, 0.6, not 6/2 or 6/4, nothing like that, not 3/2. Alright, it has to be a number between 0 and 1. Alright, so now I'm solving this. I'm going to use the same numbers that I used before. So f of negative 2 gives me 1/2 raised to negative 2. That flips the 1/2 over, and that gives me 4. Next one, f of negative 1 is 1/2 to negative 1. The negative means I flip the fraction over. That gives me 2. 0 here is just 1. 1 here is just 1/2. And now don't do this because when you start adding other stuff into it, it's going to mess it up. But I'm just trying to do this to keep the video a little bit shorter. So then f of 2 equals 1/2 squared. So 1/2 squared, the square goes to the top, goes to the bottom. So that's 1 squared over 2 squared, which gives you 1/4. Alright, now let's graph it. This was my purple function. So this is a decay. If you look at this and you have some common sense, it looks like it's growing. Here, start at negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, 2. This is what is called a decay. That means it is shrinking. So I start up here at 4, and by the end I only have 1/4. All right, it exponentially goes down. You hear about this with half-life and nuclear decay and stuff like that. You hear about growth when you're talking about bacteria. The coronavirus is a good example of that. You see those charts where it just starts off slowly and shoots through the roof. That's mostly what you see is with bacteria and stuff like that. I'm going to do 2 more, but what these are going to be is reflections of these. All right, so I have a whole number right here, and I told you if it's a number greater than 1, you're going to have a growth, and that's what this is. This one is a growth function. Only if this number is between 0 and 1, like a decimal or a fraction, not all fractions, just fractions between 0 and 1, will this be a decay. So this is a growth, even though it has the negative sign in front of it. The negative means you're going to take a reflection over it, over the x axis. All right, so f of, I do the same numbers again. Again, you can use whatever numbers you want. These are just the ones I've always used. This equals negative 3 raised to the negative 2. Notice I keep the negative on the outside. The negative does not go to 3. The negative is its own thing outside. You do not square the negative. So that's a negative number. Negative stays on the outside. Flips the 1/3 over. Then I square the top, square the bottom. Gives me 1/9. So f of negative 1 gives me the negative, flips the 3 over, top, bottom, 1/3. All right, and then for just speed's sake, gives you negative 1, and then negative 3, then 2 gives you negative 3 squared, which gives you 9, negative 9. All right, and now let's graph this. Orange. So negative 2, 1/9, negative 1, 1/3, 0, negative 1, 1, 3, and then 2, 9. As you can see, just switching that number from 2 to 3, if you go back and look at the other one, which is this one, which is the other growth we had, all I did was take a negative and I switched to 3. It's growing much, much faster. So this one only got to 4 by 2. This one's already at 9. And it's going to continue that way because this is tripling every time. This one just doubled. All right, so all I did, this might look like a decay because it's going in the negative direction. What this is a growth in the negative direction. It is still a growth, just in the negative direction, because it has a whole number right there. Or it doesn't have to be a whole number, it could be an integer or anything, as long as it's a number greater than 1. Alright, now we're just going to do reflection with the decay. The decay is a decay because that number is between 0 and 1. Anything between 0 and 1, you're shrinking it down. So I'm going to do the same numbers again. I know this gets tedious, but these are the best numbers because it gives you on both sides of the x and y. I believe that's why I do it. I don't know. I was just showing that way to do it, and I've always done it. So the negative flips to 1/3 to make it 3. And then 3 squared is -9. Oops. Let me switch my colors. I don't like it looking just one straight color. It gets weird. Raised to the -1, that gives me -3 raised to 1, which is -3. So it's 0, so I'm just going to put -1, and then 1 will give me. Again, please don't do that. Plug everything in for it, because they always won't be this simple. You'll throw in a horizontal asymptote and a coefficient in front that changes the entire thing. -3, -1/9. Alright, so let's graph this one. -2, 9, -1, 3, 0, -1, 1. And there you go. You got 2 growth functions, 2 decay functions. This might look like the growth right here, but it's not. It's actually decay, just reflected across the x-axis. Alright, this has been just a basic exponential functions video, like how to basically solve them and graph them. It doesn't get much more basic than this. Hope it helped, and good luck.